Hey there, friends. This is Bill MacDonald, the Common Sense Math Doctor, and I just have a quick question for you before we get started on this question that only got 18% in the entire state of Texas on a May test. What do you think happens if we only teach one way all year long to an entire classroom, grade level, district, or across the state? If we always use one program or one curriculum, it's going to collapse when it gets to its weakest point. And so if we don't differentiate our instructions in terms of the ability level of our students or the way that they learn, it would be like taking one of those 6 things you see behind me and removing them as a method of learning. If I'm a hands-on learner and you tie my hands behind me, I'm not going to get it. If I'm a visual learner, but you don't let me use my eyes in a very specific way to look and see something, there's going to be a gap in my learning. If I'm a verbal learner and you don't let me open my mouth, if we require or let students who are auditory learners take their tests completely silently without opening their mouths, silence is deadly in a classroom of auditory learners, because right next to the mouth, the tongue for taste, is an ear. And he who has an ear, let him hear, not just hear, but actually listen. Because even though we joke around about Charlie Brown's teacher, want, want, that happens in every single classroom in America where kids are hearing us, but they're not really listening, because there's a saying that I truly believe that every 5 minutes in one classroom, one student stops listening. And because of what's happened in the last year and a half, that has probably multiplied exponentially, that possibly every 5 minutes in a classroom, 2 students stop listening. Now, if we can utilize as many of those senses as possible when we're teaching any subject or skill, then that brain connection, we can really think, which of the 5 senses plus 1, because the tongue can be tasting, which I'll address in today's problem, but can also be speaking, opening your mouth. And so let's be careful not to limit ourselves to one curriculum, one program, one specific way, because if only 18% of the students in Texas got a question like this one correct, then something is missing in whatever is being used. So we need to supplement. And I have a lot of kids that I taught that were GT. They were gifted talkers. But for some reason, we let them get away with being silent testers and wondered why they struggled. Some kids will get it, but they just need ET, not extraterrestrial, but extra time, more time to practice the skill, or extra times working on that skill a little bit more often. So I want to encourage you that your kids are ED, not emotionally disturbed, even though some of them have been affected emotionally by all that's happened in the last year and a half. But ED in Bill MacDonald's common sense math world is explain differently. How can I, as a math doctor, teach this skill so that more kids can remember than 18% in May? And so at the end of this video, I really want to encourage you, if you haven't already purchased my 4th, 3rd, 5th, 6th, 7th, 8th math surgery tests, I would highly encourage you to do so, because like I mentioned, I'm going to take the time, whether you buy them or not, to go through every single question of every single problem for those of you who need to help your kids learn a different way. Now, notice I didn't say the way, a different way to teach skills that are very hard. Teaching math or any subject is not assigning a worksheet or a computer assignment to kids. Those are called worksheets. One of my favorite math consultants said, give kids sheets that work. Sometimes it has nothing to do with a piece of paper, but coming off the paper and using one of these senses or speaking that can directly tie to the problem. And so that's my soapbox. Let me get straight to the problem so that we can learn a way to teach a question that I modeled after the most difficult math question based on percentage correct that the students in Texas have ever struggled with. And so if you notice right there, it came from question number 15 from this past year's test, the 2021 fourth grade test. Only 18% got it correct. And in Texas, everyone, we test in May. So we had all year, we had 9 months, 10 months basically to teach a skill that we call reporting category to student expectation 4.4H, and it's readiness. And apparently they weren't ready for this readiness problem if they went into 5th grade with that kind of percentage. So if you teach 5th grade, then I would highly suggest that you get this math surgery practice test, because it's a combination of the last 2 years, the 2019 and the 2021 most difficult questions. Now, do we have kids who struggle with reading? Yes. So if you have kids who struggle, they're going to have to read 1, 2, 3, 4, 5 sentences. And because this is one that happened to be a good response, it would be a total of 7 sentences. And sometimes kids struggle with reading 7 words. So let me zoom in on just the questions, the key words that have to do with numbers and the words that follow them. I know that there's 15 packages of M&Ms, so I need to visualize that. Not one package, but 15 packages. And a quick teachable moment, M&M is one of the few candies that don't take the time to capitalize the name of their candy. They have somehow decided that they're beyond the rules of capitalization. And so what change should be made on the candy bag? Place a capital M and a capital M on the candy because she was hungry. Nope, I'm going to skip that. She ate all, because all is a number. I got to figure out how much she ate. What do you mean by all? The M&Ms in one of the packages. Each is one. of the remaining package, 24 M&Ms. So I've got 15 packages. I ate one of them. I have 14 packages. Those 14 packages have 24 M&Ms inside each. I see each in the problem here and in the problem here. One of those means multiplication because of the way it's worded, and one is division. Problem multiply. PM. What I might have your kids do is take a look at the mathematics chart that comes with the test. At the bottom left in the place value section, you're going to see keywords. Are they the same? Like 15 packages. They ate one package, all the M&Ms in one package. Then you could add or subtract. If they're different, package M&Ms, those keywords are different. So you'd multiply or divide. And so those are a couple of things that you can help those kids who struggle with how to dissect and break down this. Now, the problem is it just didn't stop there. It's already given us one step to get rid of the M&Ms in one package. The second step is letting you know, hey, every single one of these packages that are left have 24 M&Ms. Then they said, oh, let's take it one step further and take all of these remaining M&Ms and place 8 of them into each bowl. So whatever the total is, problem multiply, we're going to take that total and be placing them into bowls. So the question is, what is the greatest number of bowls? Since number is a number, I'm going to make sure I zoom in on that they could have put M&Ms into. So the number of bowls. So once we're done, it's not multiple choice, which made the question even harder. Use the answer document below, use the correct place value. So let's bring this problem to life by taking what we know. They said there were 15 packages of the M&Ms. They ate all of the M&Ms in one package. So because package is the same as package, we can add or subtract. Let's take away one package. I have 14 packages left. Okay. Step 2. I have 14 packages and each package has 24 M&Ms. And so because those keywords are different, a package is not the same as an M&M. In other words, you could eat an M&M, but you can't eat the package unless you're really hungry. Okay? Because my chart said, when the keywords are different, I might multiply or divide. And so because many kids know a quick check strategy, diff, multiply, or divide. Because every single one of the packages has 24, I'm not separating them. I'm going to be figuring out how many total M&Ms because I know that my last step is to take them and divide them into bowls equally. So to help those of you who have kids who struggle with 2-digit or 3-digit multiplication, I'm going to show you in my mathematics posters an activity that I call tic-tac-toe. Okay, I'll show it to you really quickly. It's in my mathematics posters. Tic-tac-toe. What I've done is used a 3-digit factor as the top number and a 2-digit factor as the bottom number. And we use Spider Woman as the red number. And we do all of the multiplications thinking of Spider Woman as a person who makes webs. And so she has to make webs from the floor to what we will call these three buildings one at a time, come back down and do her carries. And then, so Spider Woman's total is 2,832. Then we play tic-tac-toe. The tick, we cross off the X of Spider Woman because she's done. The tack, will place a 0, XO, and O down below because Spider-Man is not in the ones place, it's in the tens place. So we will do tick, we will do tack, and the toe is to place X's, XOX, on all of the carries so you don't accidentally use Spider-Woman's carries when you're doing Spider-Man's work. So it's best to erase these webs and do it over. Again, you would now have Spider-Man and he would climb to the building, and think of all spider heroes, all superheroes as right-handed. They move to the right first when they're doing their multiplication. That's 2 10s times 4, 2 10s times 5, come back down the building, 2 10s times 3. And so I change the colors. So I highly suggest that the first or a couple times that you're teaching 2-digit multiplications on the bottom, then use 2 different colors. If you're teaching 3 digits on the bottom, then use 3 different colors. So you can see, this is the number in the ones place, the tens place, and you could perhaps use green or orange or purple for if you have a digit in the hundreds place. So your final answer would be 9,912. So that's how you do tic-tac-toe, but let me show you how to do it with our actual problem that we have here. We have 14 packages. Each one has 24. So Spider Woman says, let me climb this building. 4 times 4 is 16. Come back down the building. Carry the 1 over. 4 times 1 in the tens place is 1 plus 1 more 10 would be 5 tens. So now that Spider Woman is done, we play tick, cross her off, tack, place a 0 down below, an O, so that we remember that Spider-Man is in the tens place. And then toe would be to cross off your carries. And then just to be sure that we don't get confused with the webs, erase the webs, and Spider-Man would move to the right as we mentioned. In the tens place, 2 times 4 is 8, no carry. Climb back down the web because some kids will try to go left and right. 2 times 1 is 2. What does that mean? 56 means 56 ones, or it means 5 tens and 6 ones. 280 ones means 28 tens, or it means 2 hundreds and 8 tens. Why am I saying that? Because a lot of questions ask your kids about place value, the different ways to say numbers. So the first step is, how many M&Ms do we have so that I can take them and place them into the bowls and find out the greatest number of bowls? Why did I draw a picture? Because a picture paints 1,000 words. Well, 1,000 words need to paint just a couple of pictures here. So write this down in your notes. Your arms are connected to your hands, which will draw a picture, because in some cases, artists will remember more story problems. Let me draw a picture of this story problem, this word problem, one piece at a time. So our total M&Ms, plural, are 336. Then it said, the next step, she's going to put 8 M&Ms into each bowl. Again, an M&M is not a bowl. So you would not add or subtract. You wouldn't subtract 8. You're taking the total and we're dividing. So in order to find out the question, what's the greatest number of bowls that I can use? I'm going to have to use division this time and say, okay, well, let's draw one bowl before I can find out how many total bowls that I might have. What does one bowl look like? So I got 8 different colors of colored pencils and I placed them into one bowl. So since I've only used one bowl, I've only gotten rid of some of those M&Ms, and I'm going to keep doing that, dividing until I lose all the M&Ms, until I either have none left or until I have some M&Ms left that might have 1 or 2. And since the question said, what's the greatest number of bowls they could have put the M&Ms into, if there's any remainder, any left, I would need to have an extra bowl for any that happened to be left. So what I did was I printed out my next page that will help kids who really struggle with division. When I fail division with an F, my mom gets really red. So Ma's red is just a simple acronym. Mom, I failed division again. And we're going to call it 5 easy steps to dividing numbers. Here they are. We're going to multiply something, a number in the divisor, until we get an answer that is inside our box, our dividend, into it. We get that number or less. Then we'll subtract that number to find a remainder. How many are left once we subtract? Then we've got to decide if there are more numbers left inside the dividend, we would have to drop and go back to the top and do all of this again. If there are no numbers left, we would be done, and that would be our quotient, the answer that you get when you divide two numbers. And for those of you that wanted that, would like that more in detail, when you purchase any of the math practice tests, I practice math read with 1-digit quotients, for 1-digit quotients, and for 2-digit quotients. Notice that it's both, in this case, 1-digit divisors, but when we need 2-digit quotients, the answer when you divide, and 1-digit quotients up here, the answer when you divide. So what does that look like in the real world? I'm going to use my mathematics chart for you. Sorry for the glare. It's shining off the light that's above it. What we have is the dividend, the numerator, the top part of the fraction is 336 M&Ms. We want to divide it by 8 until we no longer have any M&Ms left. So the divisor is 8, also called the denominator. So please be careful to make sure your kids understand that, yes, the numerator can be bigger than the denominator, especially when you're dividing a large whole number on the top by a smaller whole number. So I've done the next step for you. I've written my must read, and because you can see that there are 2 digits in the quotient, we're gonna have to go through the steps of must read twice, okay? And this is where most kids go wrong. This is probably where most of the kids struggled. This is my advanced mathematics chart, and I just went ahead and used it to kind of break down the problem. And so this part on the bottom is probably one of the most important things that I recommend you do with your kids. We're going to be dividing by 8 until we get to 3 or less, which would be a waste of time because 8 times 0 is 0, and you would still have 3 left, and it would be just kind of taking extra time that you don't need. So our first step is trying to go by 8s until we get to 33 or less. So what I highly suggest, because our first step was multiply, have your kids make a little multiplication chart on the paper they're doing their work on paper. This is too much to be doing on a computer, so make sure they have some scratch paper. And what they multiply, they put on the top. The answer, the product of what they multiply, goes on the bottom. So we're going to keep going. We are trying to find 33. So since I want to go to 33 or more, I would have to go all the way to 8 times 5, answer 40, and I went past it. So since I cannot mathematically go past the number that we're looking for, 8 does not go into 33 5 times. 8 can only fit into 33 4 times. So in the tens place, what number's on top? The 4. That's what we multiplied. The answer on the bottom is 32. So whatever you put on the top goes on the top. 4. Our answer is 32. So there's our first 2 check marks. Multiply 4. Answer is 32. The next step, subtract. So let's subtract 32 from 33, or 33 minus 32. Our RE, our remainder, will be 1. Let's check. Do we drop or are we done? Since there's another number left in the ones place, I'm going to have to drop that number, 6, drop and go back to the top. Now I have to multiply again till I get an answer that's my new product. I got to multiply by 8s until I get to 16 or higher. So in my ones place, I'll try it. 8 times 0 is 0. I haven't gotten to 16 or higher. 8 times 1 multiply is 8, the answer. 8 times 2 is 16. Multiply the answer. There it is right there. So got the number exactly. So what we multiply goes on top. Its answer goes on the bottom. 8 times 2 on the top. The answer goes on the bottom. That's my answer. So what is our next step? Subtract. Subtract 16 from 16, you get 0. 16 minus 16, you get 0. That's my remainder. Do you drop and go back to the top? Let's check. There are no numbers left, so we are done. So since there are not any M&Ms left, none remain, there is no remainder. I don't need an extra bowl to hold a portion of another bag. I will need exactly 42 bowls in order to equally divide these 336 M&Ms into bowls that have 8 each. So once again, as a reminder, since there's a 0 in the remainder, it means that none is left to place in another bowl. So if you were to do an extension of this problem and just say that they left one of the M&Ms from that package that we ate on the table, then you would need 43 bowls, and that last bowl, like the ones that we drew here, that last bowl would only have one M&M in it, but we would still need a bowl to place the M&M because it can't be left out. That's been asked many times by your students, by the state. So the final answer is 42 bowls are needed That's the greatest number that we're going to need. So we'll place a 4 in the tens place. Bubble in before we forget. And we'll place let me make sure I put the right number, a 2 in the ones place. Bubble it in before I forget. So we need 42 bowls and nothing else. So you can leave that part blank, or you can have your kids practicing. Just remember that after every whole number, even if the decimal is not there, you can remind them that there's always a missing an imaginary decimal at the end of every whole number. So our final answer would be 42, if I flip it over, and no tenths, no hundreds, there's no remainder, so there's no portion of another bowl that we need to use for that. So 42 would be the final answer. And as you notice, because this problem had 1, 2, 3 huge steps, and because kids either did not know how to multiply, they didn't know how to divide, or understand that these 1,000 words can be broken down into pictures, they would have gotten lost somewhere along the way, which is probably what happened. So if you have not taken the 2021 test as a benchmark, I highly suggest that you practice this 2021 surgery. And I'm just going to take a quick moment to remind you that all of these multiple choice, or in this case, grid responses, have a constructed type response portion to practice open-ended, because starting next year in math, reading, science, social studies, algebra, US history, there's going to be a portion of questions that are open-ended that will be worth 1 point for the constructed type response, the grid responses, and sometimes there's going to be 2-point questions where you just can't tell us the answer. You sort of have to explain in math, what numbers did you use? Where did you get these numbers come from? So you'll have to kind of take it an extra step, and there's going to be 6, 7, 8 questions like that. So I hope that this kind of helped you. You might not utilize or adopt all of these strategies to your math teaching toolbox, but I think whatever we were using last year, 2021, was not enough in terms of the differentiated extraction. There weren't enough different ways to teach those 3 steps of math so that your kids could arrive at the correct answer. So please do me a favor and share or tag your math teacher friends, because to me, 18% is extremely low of a number. And you may not have seen this statistic, but when I was comparing all of the tests for 2021 to each other, 7 out of the 12, fourth, third, fourth, fifth, sixth, seventh, eighth, and ninth, the algebra, all 7 were 7 of the lowest performing tests in terms of percent correct. And when I say percent correct, I mean 18%. Anything that gets lower than 60% correct, in other words, only 50% of the students or less got that question correct, then something was either very rigorous about the keywords in the question, the way it was taught, the way it was tested, related to maybe a different way that we taught it. So I highly suggest that you take one of these ideas and run with them, add it to your teaching toolbox, make some graphic charts, an anchor chart that you can put on your classroom wall. If you already purchased the test, then you should have received the mathematics posters. Make sure every kid has a copy of Mass Red and the Spider-Man, Spider-Woman method of multiplication. That's a way to teach it, where we get to add in tic-tac-toe. One more added bonus: if the reading of the problem and the question is the appetizer, then the underlining and the labeling, the execution would be the meat and the vegetables, and then selecting the correct answer would be the dessert. Since we were talking about M&Ms, you don't need a million bags, but for $1 at Dollar Tree, you can buy like 25 packages. So for $2, you can buy these 42 bags of M&Ms and be able to bring this math problem to life that I used. And the reward would be anybody who makes it through all of the steps would get all the dessert. But if you want to reward progress for each step your students can get through correctly, then give them an M&M or two for when they get rid of the package of M&Ms that was eaten. When they're able to correctly multiply the number of packages left times the number of M&Ms that are in each package, a couple more M&Ms they get to eat. When they're able to correctly divide the dividend by the divisor to make the quotient and realize that there are no remaining M&Ms. Another one, if they can draw the picture correctly of at least one bowl, you can place that. You could have several pictures so that artists can remember more story sequence. And then finally, if they're able to transcribe from their paper that they took notes on, where they worked it out, over to the grid response and be able to correctly put it in, that's real important. Just take that teachable moment of instruction. TMI is not too much information, it's teachable moments of instruction. And in the case of this problem, because it scored so low, it's a teachable moment of intervention. We have to figure out a different way to do this. So the final answer was 42 ones or 4 10s and 2 1s. And it's real important that I say that, because several of the place value questions are asking you to analyze different ways that a number can be spoken and written. So God bless you guys. Have a great day and good luck this next several months with your students in math, reading, writing, social studies, science,